Today I want to give you an honest analysis if local AI coding is actually good. Now I want to look at this from a practical standpoint. I have a pretty high-end machine here. I'm going to run a few local models and show you how fast they are, the quality of the output, and compare that to something like Claude models. But I just want to be brutally honest with you because a lot of people on here will tell you, local is the wave, everyone should run local models, and I don't know if that's entirely true, and I want to get into that in this video. So first, let me share with you the specs that I have here. So what I have is an RTX 4090 with 24 gigabytes of VRAM. I have 64 gigs of RAM on my machine. I believe this is DDR5. And then I have, a high-end CPU, a lot of memory, etc. Really, the only thing that matters in this scenario, because I'm on a Windows device, is the amount of VRAM I have, which is 24 gigs. Now that effectively means that I can load models that are no larger than 24 gigabytes in space, and that's going to limit me to about 30 billion parameter models, depending on how I configure them and the quantization that I'm using. Now I have also done experiments like this on my Mac. I have an M5 Max with 64 gigabytes of unified RAM, and while I can run some slightly larger models on that device because I have more RAM or more unified memory, I found that I'm still limited to pretty much the same models that I'm going to be running here if I want them to run with any type of reasonable speed and actually be usable. Now I'm sharing this with you to be really upfront about the cost. If you want to run even decent local models, you need very high-end hardware, and most of you would be better off buying a cheaper computer and spending a few $100s on maybe some different AI subscriptions over the year to get your quota and use even better models in the cloud. So understand your use case before you just go and spend $6,000, $7,000 on a computer to run a mediocre local model, and that's why I'm making this video, so we can be really upfront about it. That said, there's still a lot of reasons you would want to use the models, and I'm going to show it to you here, so let's dive in. So there's 3 or 4 major things that you want to look at when you're comparing any type of coding models, and especially local models. Now the first and most important for me is speed. So how many tokens per second are we getting, and is this actually at a speed that feels fast, it feels snappy, and I'm going to be okay using that for a majority of my coding work. The next is going to be quality of output. Now this is effectively how good is the code, right? How many times does it make mistakes? And am I comfortable using this for, more advanced coding tasks where I want it to give me a pretty high accuracy? Of course, we're not going to expect a local model to compete at the same level as Fable 5, but it should give us reasonable results, right? Where we're okay with the output that we're getting. Next is going to be compatibility. A lot of the AI coding tools that you use don't work natively with local models. Running something through LMStudio or Llama typically will work, but you might be limited in the number of features, or the agent harness that's created may not work with it right away. This is something I discovered a lot when I was messing with these models, is that oftentimes it was a bit of a headache to get set up, and in a real world scenario, there's some features you don't get access to that you really might want. So keep that in mind depending on how you're running it. And then last thing is going to be cost. Are we actually saving money if we compared how much we would have to spend on the tokens ourselves running through something like the Anthropic API? And then the last major reason, which I think is the biggest sell for running models locally, comes down to one thing, and that's control, right? You can pick the model, you own the setup, and nobody can change the deal on you once you have it downloaded. One of the problems you're going to run into is that almost every tool that you'd actually want to use locks you into one provider's model. Now that's exactly what MindsHub Cowork, the sponsor of today's video, is built to fix. Now it's open source, free to use, and it has a real model router. So you can run Claude, GPT, Gemini, DeepSeek, or the same local models that I'm running in this video, all inside of one workspace. Now the workflow is simple. You brief the built-in agent harness, it's called Anton, walk away, and come back to finished work. So I asked it to research the latest coding models and build me a comparison dashboard, and this is what it came back with. An actual dashboard that I can open and share, not just a wall of text. And this is the part that connects everything in this video. When a better model drops, whether it's local or a cloud model, I can swap it in and rebuild nothing. Same workspace, same work, and since it's fully open source, you can clone the repo, spin it up locally just using a few commands, or download the Mac or Windows app. The whole thing runs on your own hardware, which is basically the entire goal of what we're doing today. Now they also have a hosted version, but honestly, I love the desktop application as it's very easy to use. I'll leave a link in the description if you want to try it out. Now let's get back to the local models. All right, so I'm on my computer now, and I want to show you some of the different models that I've been testing and that I'm going to show you in this video, because I've gotten really different results from many of them, and there's one that I much prefer to use. So you can see that I have this Mistral model, Devstral Small. It's about 24 billion parameters, 15 gigabytes in size. And when I'm using that model, I can have a context window that's a little bit larger than I would normally have because I have a bit more overhead to fit that on my GPU. Now I have a Gwen 3 model here. This is the Coder 30 billion. It's 18.6 gigabytes with 30 billion parameters and 3 billion active parameters. This is a mixture of experts model, so it allows me to have slightly more parameters than I would typically be able to load because not all of them are going to be active at the same time. I also have this small model. This is what I would use for autocomplete, depending on what tool I'm using, just like a really quick kind of tab completion model. Then I have this Qwen 3.6 27 billion parameter model. This is a full dense model. That means all of the parameters are active, so it's a little bit slower for the inference. And then we've got Google's Gemma 4. This is significantly smaller. I haven't played with this as much, but I figured I would just try it out and see what we got. Now for all of these models, I've got them in this Q4KM quantization type. That just means that they're a little bit smaller so that are able to fit fully on the GPU. And this is the important thing you need to know when you're running local models. You need to be able to fit the entire local model in your video memory or your unified memory, depending on the operating system that you're on. Otherwise, they are going to be sluggishly slow. So for example, previously I even had this model and I'd cranked the context window too large, and because of that, it started overflowing into my normal system memory or my normal RAM, and that caused my performance to go from I think like 70 or 80 tokens per second to 2 tokens per second. So you need to be able to load the entire thing on your GPU, and that is really the main bottleneck when it comes to doing this. However, and this is something I found out the hard way, you also need to consider what else is potentially running on your GPU if you're using your computer or in your unified memory, right? So for example, like when I'm coding, I don't just have VSCode or one editor open. I have maybe Google Chrome, I have maybe Slack or Discord or other software. You have to keep that in mind because those are using system resources as well. And I found that when I got really close to kind of the top end of the RAM in my GPU, all of a sudden my entire computer started lagging. I couldn't even move the mouse around. So a lot of the settings you're going to see here when I start running these models, I was fine-tuning them and adjusting them so that this was actually usable on my device. So don't just purely look at the size here, look at, okay, what else is actually going to be running on my machine, which is something I found out the hard way. Okay, so these are the models that I have. Now in LMStudio, it exposes a local server where you can load multiple models inside of here and then have them available to different devices on your machine or different applications on your machine. So right now I've got the Gwen 3 Coder 30 billion parameter model. This for me has been the best performer because of the mixture of experts architecture and runs the fastest. I'm going to show you how to use it in VSCode. So from VS Code, it's pretty easy to set up this model. What I can do is just open the command palette. I can go to manage language models. And then what I'm able to do is just add an LMStudio instance here. It looks something like this. I'll show you the JSON config where I put the URL. I just configure a few things like the context window size, and then I put the ID of the model. From there, it will allow me to access the model in the integrated chat window. You can see that I can go through and I can select the Qwen ones, or I can select the Sonics. I've also enabled Anthropic via API billing. So for now, let's switch, to the 30 billion parameter model, and we can just run a new chat. So I can ask it to do something simple. I'm going to say, build me a fully featured Tetris game using JavaScript so that this runs in the browser, make it modular so that we have it in separate files, and make it have a leaderboard and store all of the scores so that I can see who has the best score. Okay, so we're going to give it a prompt there. Go ahead and press enter. And I just want to show you the speeds that we're getting. And I also want to note why I'm using VS Code. Now, this is what I found to be one of the main bottlenecks when using local models. This is the compatibility with the agent harnesses that you would prefer to use. So in my case, I prefer to use Cursor. I find it's one of the best agent harnesses. It performs better than Codex or Claude Code, even with the same models, but it's really tricky to configure LMStudio or Ollama models inside of Cursor. You can do it, but you don't get the same features. You don't get the same tool calling like you would get with native Cursor models. So not only do I have to say, okay, what model is going to perform best, but I have to say what models are actually compatible here to be able to use the harness I want. So even using this inside of Claude Code, for example, you can do that, or you can use this inside of some other tools, but I want it in like a full kind of IDE environment. So that led me to pretty much just having to use VS Code, and even inside of VS Code, it doesn't get the same set of features that something like an Anthropic model would get. So it's pretty good. It can call most of the tools. You can see it's making this to-do list, right? It can change the files. It can actually create stuff, which is what I needed to be able to do, this kind of agentic capability. But, it's not as good as like the standard Copilot model, right? Or whatever models are built in. So that's the main bottleneck I found with these local models. And that alone is one of the reasons why I can't purely use these, because they don't work in all of the harnesses that I want to be using. But regardless, you guys can see that this is going pretty fast. I mean, it's writing like a good amount amount of code for me right now. And if I open up LMstudio here to kind of look at the results, you can see that we're getting, where's the token per second result? This is just processing the prompt. Let's wait for it to give us something else. Okay, so actually it beat me with speed here because I came back and it's already finished. And if I look here, this is the game that it actually built for me. So I don't know, let's go start game. And you can see that I can move down, okay, and it's a fully functioning Tetris game. Now, I'm not trying to say, oh, this is a super impressive game. Of course, AI has been able to make this for a long time, but the point is that very quickly, like I hardly did any cuts here when you guys are watching this video, it generated the entire game for us, and we have usable code that we can scroll through and see, probably looks pretty decent. Okay, so let's close this for now, and let me ask it to build something else because I want to get you guys the speed of this, which is the whole point, but you can see that it was running quite quickly, and I mean practically gave us something relatively useful. So let's ask it something else. Okay, this is good. Now can you make a Mario platformer game for me, please? Same thing, it should work in the web interface. It should be fully modular and fully featured. Okay, let's press enter and see what we get. Okay, so here we go. We can see the token per second streaming here. So we have 83 tokens per second, 75, 78, and this lines up with my expectation where previously when I wasn't recording a video at the same time, I was getting 80 to 90 tokens per second. This is very fast. This is gonna be faster than even using something like Fable in high thinking mode because of all of the reasoning that it's doing. So this is pretty much as fast as any cloud model that you would want to be using. And again, it's giving us like pretty good results here from VSCode. And it says that it's already fully built out the game. I guess let's try to run it and see what it looks like. Let's reveal it and let me just open it up here. Okay, and start the game. And okay, it looks like something's clearly broken. So, we didn't get a perfect result here. That's just how the local models work. But point is that it's very, very fast. So now let me just switch over to another local model to give you a sense of kind of the difference if we run a fully dense model in terms of the speed there. All right, so I'm going to load up the Qwen 3.6 27 billion parameter model. Notice this is less parameters than the last one that I had. However, this is a dense model, meaning it's going to run through all of the parameters. It's not using this kind of mixture of agents or experts architecture. And I'm going to give you guys a hint here, or kind of a tip. When you're loading these models, enable the Kcache and Vcache quantization, cache here. When you do that, as well as the flash attention, it's going to drastically reduce the amount of space that the context window is going to take up, and it's just going to give you less RAM being used on the GPU. So for example, if I disable this and I just turn these off here, you can see that we go up to almost 24 gigs, and just purely by me enabling these, right, and putting this back to Q8 and Q8, you can see we go down to 20. So we save about 3 gigabytes, which is enough now for me to be able to fully load this on the GPU. So let me load up this model. It will take a second here in the API. And then what I can do is same thing, switch it over in VS Code and show you the difference in speed. Even though it's a very similarly sized model, you're gonna see it's a lot slower. So if I go here and I run my Qwen 3.6, let me now ask it to try to fix the Mario game. The Mario game is pretty messed up. It's not working properly. I don't see any characters. When I press start, nothing happens. Can you fix this and make it better? Okay, and let's see what we get. Okay, so immediately when we go to LMstudio, you can see that it is a little bit slower. The first thing it needs to do is process the prompt, which did take probably 2 or 3 times longer than we were getting with the other model. Okay, and then if we look at, it didn't give us tokens per second yet. There we go. You can see we're getting about 30 tokens per second in between all of the prompts or conversation messages. So 32, I think we'll see like 33, yeah, 32 tokens per second. So this is still quite fast. This isn't a slow model by any means, but if you're used to using very fast cloud models, then you definitely will feel the difference. And you'll see here that it's not kind of instantly blitzing out the code like we were getting before. It's taking a little bit longer. And again, this is about 2.3, 2.4 times slower, purely based on the architecture that's being used. That said, when I've used this model, typically I've gotten slightly more consistent responses, I believe because the performance is a little bit better with the fully dense model compared to the mixture of experts. Now, one thing to notice as well is that this speed is going to be dependent on the fact that we're using this coding harness. If I were just to chat with the model and just give it like a basic prompt where it's not passing in tool calls, it doesn't need to do as much reasoning, it's not like thinking through everything, right? Or we don't have as much coming into the context window, it will feel snappier, faster, faster, will give you really good replies, but I care about how this works with coding, which is why I'm showing it to you here. And just to be fair to our previous model there, I noticed that it didn't actually write out all of the JavaScript files. It said, next, I'm going to do this, but it didn't automatically proceed to that. So that's, of course, why the game didn't work. So I guess I just missed that in the prompt. But anyways, let's see what we get here with the other Quen model. Okay, so it's just wrapping up now, and we just ran into an error that I want to show you, which is what I was talking about with the compatibility of the harnesses. So this just completed everything. It wrote all of the code and made all these new files, marked everything off in the to-do list. But as soon as we got to test game in browser, it was able to open this up in the browser, but then it immediately failed. So this is the thing. Some of the message requests or payload structure, however the harness is set up, don't work properly with the local models, where I just get an error now saying, hey, like it wasn't able to do this, whatever. And it can't do the interactive testing like, for example, a composer model might have been able to do. Okay, so I mean, I can test this myself, although it doesn't seem to be working. So I guess there's some kind of error here that we would need to fix. But you guys kind of get the idea, right? It's like it works. It's relatively fast. I mean, it definitely feels slower than using a cloud model, but then we run into some issues like this where it's like, okay, I don't really want to deal with this too often. I would probably prefer just to switch over and use a Claude model, for example, or GPT or whatever, where it's able to have access to that feature. So now what I'm going to do is I'm just going to quickly run a few prompts through some Claude models using the API billing, similar ones to what we had here, just to show you kind of how much that would actually cost. Now, keep in mind that in practice, it's going to cost you a lot less because you'll probably have some subscription that's going to be massively subsidized. But for example, if I switch the model here over to, let's go with something somewhat comparable, maybe like a Sonnet 5, which still is going to be way better than these. Let me just ask it to, build out kind of its own version of a game, and let's see how much that actually costs in tokens. Okay, so I just deleted whatever's in this directory, and I'm going to say the following. Can you create a fully featured Tetris game and then make a fully featured Mario platformer game, make them in 2 different directories in this folder, and then make them both available via the web so that I can just use them in a normal standard, HTML browser. Okay, and we're using Sonnet 5. I have it connected to API billing, and let's see how much it costs. Okay, so it's been a few minutes here. I can't say that this is super fast. It feels like it's running maybe slightly faster than the first model I had. So maybe we're looking at, 80, 90, 100 tokens per second. I don't know exactly, but you can see that it actually opened up the browser. It gave us a usable result in the first try. So we didn't have any mistakes. It built everything out. It didn't ask us to, continue building something. That's also due to the fact that it has a much larger context window that it can use because I just can't fill too much on my current GPU. Now, it also built both the games in a way where I can just navigate between them. Personally, I think it looks nicer than what we had before, gives us like the shadows. So it is a better, higher quality result, even though we're not using, the highest end model from Anthropic here. Now, in terms of cost, if I just bring up my Anthropic dashboard here, we can see that at least right now, let's give it a second to load, we've used $2.42. I mean, it's definitely not cheap for what it is that we got, but it's not extremely expensive. And this is the most expensive possible way that I could run this model because I'm doing it in the API billing. Now, of course, if I switch this to Fable, it's going to be probably 5 to 10 times more expensive. I'm sure, yes, we'll get a better result, but it's not going to be that much faster. And yeah, it's going to cost us a lot of money. So there's, of course, a lot of other experiments I can go through here, but I want to give you kind of my verdict because it's not really clear. Should you use local models or not? So here's my honest, no bullshit analysis here. Local models are pretty good. They're good enough. They're satisfactory. They're adequate if you have really high-end hardware. And, I'm talking about running expensive hardware that most of you probably do not have. For me, am I going to use local models for a majority of my coding? No, I'm not. I'm going to use cloud models because the cost is still relatively low. I have the subsidized subscriptions and I get a better result that's oftentimes faster, and I have access to higher levels of intelligence that I just can't do locally. However, if you told me that I had to use local models for some reason, if I was extremely cost constrained, if I didn't have access, or I was really concerned with privacy, I would have no problem coding with the current models that I have. It feels like I've just gone maybe 6 or 8 months back in terms of what I had access to then, and I can still create great software, I can still automate a lot of my workflow, and I can still generate massive amounts of code that will save me, tens of hours per week if I was doing software development as a main job. So I think really the answer here is you probably are going to end up using both. If you're on really low-end hardware, I wouldn't even bother. The models that you're going to be able to run just really aren't going to give you any kind of decent output, and if they can, they're going to run extremely slowly. Now, with that said, should you go buy a $5,000 computer so you can run local models? No, same thing, absolutely not. You'll get a much higher quality model that will be capable, that could do something that maybe you're going to use on an airplane for a few hours where you have no internet access or you run out of quota, but it's not something that would be relying on day to day. Really, I think local models are at a stage where they're good, they're usable, they work in a lot of situations where, yeah, you need to save money or you're running tons of different tasks, 24/7, and you're constrained to something like API billing, so you can bring in an Llama model or something like I have here, and it actually will get the job done. And if you're someone like me and you just so happen to have high-end hardware, it's a nice kind of secondary model you can switch into if you run out of your quota, or if you just want to run something fully private, fully local, and you don't care that you're going to get a slightly worse result. That's kind of my analysis. 95% of people out there should probably be running all of their stuff through a cloud subscription. The only time running local models really makes sense to me is when you absolutely need the privacy and you cannot send anything to a third-party provider, or you're doing something that's not coding related, where it's a chatbot or a customer support agent, or it's running like maybe your AI agent in, Hermes or something, and you're doing 24/7 tasks where the cost actually really will stack up. For most of us coding, compare the price of buying a new GPU to just paying for the tokens that we need or the subscriptions, you're still probably going to be better off just paying for the tokens. And even if it is more expensive, factor in you're getting a significantly better level of intelligence, a higher quality result, and it's going to save you more time than the quality of the results you're getting from these local models. That's not to say I don't think local models are great. I'm going to keep covering them. I think they're going to keep getting better and better. And I'm really excited for the day where I can make this video and say everyone should use local models. It's the best thing possible, but we're just not there yet. And that is my honest analysis. Anyways, guys, that's all that I have for you. If you enjoyed the video, make sure to leave a like, subscribe, and I will see you in the next one.